Today we're going to take what we've learned in this chapter so far and we're going to apply it to solving actual equations. This is 12.9. Let's say I have an equation that looks like this. We have a fraction on both sides of the equation. So the easiest way to solve this equation, when I just am limited to two fractions, one on each side, I don't have anything else added to either one of them, I can cross product. So I'm going to multiply across the equation sign. Now that's 12 times x plus 2 and 4 times x plus 5. Okay, one's on one side of the equation, one's on the other side. Don't forget that you're going to have to do distributive property because it's not just 12 times x, it's 12 times 2 as well. So that's 12x plus 24 is equal to 4x plus 16. And then I'll solve. I'm going to subtract the 4x. That gives me an 8x. I'm going to subtract the 24. That would give me a, let's see, negative 8, if you will. I think that's correct. And no, that's not right. Yeah, it is. Okay, negative 8. And so then when I divide, I'm going to get a negative 1. Negative 1 does not make either one of these fractions undefined. In other words, when I plug it back in, I don't get 0 on the bottom. Wait a minute, that's why I did wrong. That's a 5 right there, so this is 20. So that's going to give me a negative 4 right here. When I subtract that, which is going to give me a negative 1/2. That looks better. All right, now I want you to try one. Done the exact same way, so you can pause the video and come back to it after you write it down. All right, you guys work that out. All right, again, I've got a fraction on each side, so I'm going to cross product. So I have 2 times x plus 3 is equal to 8 times x minus 6. So that's 2x plus 6 is equal to 8x minus 48. I'll subtract the 8x, so I have a negative 6x. I'll subtract the 6, so I have a negative 54. And when I divide, I get a positive 9. 9 does not make either one of these undefined, so that's the correct answer. Now that's one type of problem that we're going to have with the equations. That's probably the easiest type. And then we'll move on to one that's going to involve finding a common denominator. You have n minus 2 over n minus 3 over n minus 6 equals 1 over n. There's not a right or a wrong way to start this problem, but what I would do is I would look across the board and I would say, do any of them already have a common denominator? Well, if you'll notice, this first term and the term over here on the other side of the equal sign have a common denominator. So what I'm going to do is I'm going to take this term right here over to this side, and I'll take this term to that side. So I'm going to get n minus 2 over n. I'm going to subtract that to get rid of it over there. Minus 1n, I'm going to add this term, because see it's subtracted here. So I have n minus 3 over n minus 6. So I move that whole thing as a unit. All right, now I have a common denominator here, so I can go ahead and combine the top numbers. So I have n minus 2 minus 1, which is an n minus 3. Over an n, because remember I'm subtracting, so the denominators just get brought down. They do not get combined. So I have n minus 3 over n minus 6. Now if you've noticed here, you again can do a cross product. But this time you're going to have to do FOIL on that one because I have a binomial times a binomial. So that's going to give me n squared minus 9n plus 18 on the one side. That's what I get when I multiply those two together. And then here, I'm going to have to distribute my n, so I get n squared minus 3n. Well, when I subtract n squared from both sides, it goes away. So I'll bring the 3n over, which is going to give me negative 6n. And I'll bring the 18 over, which is going to give me negative 18. So when I divide, I get n is equal to 3. 3 does not make any of those denominators undefined, so that is my correct answer. All right, let's do another one. All right, if you look across the board, none of those have the same denominator. So it really doesn't matter per se the way you start it. The one thing I can do is I can factor that one. So I'm going to go ahead and factor that. I'll factor out an x, so I have x plus 1. All right, if you look across the board, if I went to find a common denominator in all three of those, I would have x times x plus 1. Please remember, you can't take those two x's and say they have that in common, because that cannot be separated. So you have to take the whole thing. So if I take the whole thing there, notice that is the denominator I have over there. So right now I'm really just working on this side. I would have to multiply this by x and this by x plus 1. Because this is missing the x, this bottom is missing the x plus 1. All right, so I do that, I get 5x plus x plus 1 equals 2 over x times x plus 1. When I combine like terms there, I get 6x plus 1 equals 2. Now I'm going to show you, I actually am going to get rid of my denominator by multiplying both sides by x times x plus 1. That's equal to 1, that's equal to 1. So I'm left with this. So then I just solve here. I'm going to subtract the 1. So I have 6x is equal to 1, and x would equal 1/6. Okay? All right, let's do another one. All right, again, be careful. You cannot pull that A out to say that they have an A in common, because I cannot separate that. So when I look here and I go, okay, I'm just going to work on this left-hand side to find a common denominator. My common denominator, oops, I guess I should do that in blue, is the combination of those two things. So then I go back and I go, a plus 1 times what is equal to this whole denominator. So this I'm going to have to multiply by a on the top and the bottom, because that's what I'm missing. This one I'm going to have to multiply by a plus 1, top and bottom. So that gives me that as my common denominator. So this is going to give me a negative 4a plus 3a plus 3, because I have to distribute my 3, is equal to 1. I can multiply to get this off the bottom, a times a plus 1 on both sides. Okay, that's equal to 1 right there. So what I'm left with is negative a, because I combine those two together, plus 3 is equal to, and I'll go ahead and multiply that, so that's a squared plus a. Notice I've got an a squared that isn't going to go away, so I want to bring everything to one side. I'm going to add an a, so I have a squared plus 2a, and I'm going to subtract the 3. Then I'm going to have to solve this. So I have an a, I have an a. and I have a plus 3, I have minus 1, so A is equal to negative 3, A is equal to positive 1. I go back up here, do either one of those make that undefined? And it doesn't, so both of those work. Remember, undefined means if I plugged it into the denominator would equal 0, and I'm not allowed to have that. All right, let's do another one. All right, looking at the left-hand side, okay? Obviously, this can be placed over top of 1. This right here is equal to A plus 1 and A minus 1. That is going to have to be the common denominator there. If I want to, I could do the same thing over here and go, well, you know what? I want to get a common denominator on the left and the right. I think that might be the best thing to do. We go, what's that missing on the right-hand side? It's missing an A minus 1. Okay, that's what will make this on the bottom, A plus 1 times A minus 1. I already have the A plus 1, so I need the A minus 1. All right, over here, I'm going to multiply this first one. I might as well just do it by the A squared minus 1, which is what this is factored out. So I have A cubed minus A plus A squared minus 5. And over here, I'm going to have to do distributive property with each one of these terms because I have a trinomial times a binomial. So I have A cubed plus A squared plus 2A minus A squared minus A minus 2. All right, I'm going to go ahead and combine what I can combine on the top. Over here, it's absolutely nothing. So I have A cubed minus A, or plus A squared minus A minus 5 is equal to, again, I'm going to combine here, A cubed plus A, because that's those two together. The A squareds go away because one's positive and one's minus 2. And they're both over top of A squared minus 1. If I multiply both sides by A squared minus 1, that becomes 1, so the bottom goes away, and that becomes 1, so the bottom goes away. All right, so I'm left with A cubed plus A squared minus A minus 5 equals A cubed plus A minus 2. That and that go away. That leaves me A squared. I'm going to bring the A over, minus 2A. I'm going to bring the 2 over. Minus 3 equals 0. So that's A minus 3 times A plus 1 equals 0. A equals 3, A equals negative 1. Now, if I plug in negative 1 though, look what happens when I plug in negative 1. Negative 1 squared is 1. 1 minus 1 is 0. That makes that undefined. Therefore, that does not work. But the A equals 3 does work. Let's do another one here. X over x minus 1. Go ahead and try this one and we'll come back to the video. You'll notice they have a common denominator. as it is, so I just combine like terms at the top, which gives me 9x minus 9 equals 6. If I factor out the 9, it gives me x minus 1 over x minus 1 equals 6. Look what happens. That and that are equal to 1. Does 9 equal 6? Nope. So it's empty set, okay, or undefined. Let me give you one more to try, and then I'll give you your homework. Oops, didn't get it all erased. Try this, come back to it, and see if your answer's right. I could cross product this, so, or I could just look at it and go, they both have an x minus 2 on the bottom, so if I multiply both sides by x minus 2, that's equal to 1. I'm left with x squared is equal to 4, so the square root of 4 is plus or minus 2. But if I put a positive 2 in here, that's going to give me a 0 on the bottom. So I cannot have it equal a positive 2, it must equal negative 2. All right, your homework on solving these equations is page 694, 12 through 26, even.